Yellowstone National Park is one of the most amazing places on Earth, and it's unique. It contains some of America's most stunning scenery. To understand where Yellowstone came from and why it is so active today, we need to take a journey back into the distant past of the North American continent and deep into the Earth's interior.
The geologic history of Yellowstone goes back to the formation of the North American continent.
For nearly a century after Yellowstone National Park was established, nobody realized that the park is located inside one of the biggest volcano craters on Earth. It wasn't until the late 1960s that American geophysicist Robert Christensen realized that rock formations he had been studying for several years all around the edges of the park formed a giant circular ridge. He compared his findings on the ground with a series of NASA pictures, confirming that the ring was the rim of a giant crater 45 miles across. Finding the crater coincided with another scientific discovery in California. Scientists identified a strange thin layer of ash buried underneath the modern-day soil. The ash matched material from the Yellowstone crater. Dating the soil layers proved that the ash arrived 640,000 years ago. Scientists at last had a date for the Yellowstone supereruption. Ash was later found all over the western U.S., confirming the huge size of the eruption.
We're looking at this deposit from a supereruption, and yet we're over 50 miles from the source of the eruption.
The geologists have recreated what must have happened here on the day that Yellowstone exploded.
So this is traveling at very high velocity, easily over 100 miles per hour across the land surface, and obliterating everything in its path.
It was extremely hot when it arrived here, and perhaps as hot as 1,500 degrees Fahrenheit.
In April 2006, geologists published new diagrams of hot structures far deeper under the park. Investigators saw for the first time the sleeping monster that lies below Yellowstone Park.
Our best estimates now, as we start doing the physics and the dynamics of these things, it's like a conduit of melted rock, like a chimney.
That chimney, called a hotspot, pumped up enough heat to melt the rocks of the crust and fill the overlying magma chamber, which then erupted to blast out Yellowstone's vast crater. Understanding how the crater formed was an important moment for the investigation. And yet, the ultimate Yellowstone geological question remains to be answered. When will the supervolcano erupt once again?